Alright, here we go. Another video. Just going to keep on rolling through these systems of equations, and right now I'm going to show you how to graph systems of linear equations. A couple quick problems here. You're definitely going to want to have a calculator handy. I'll do them on the calculator with you so you can see how to graph them. Okay, so real quick, what we were learning earlier was solving systems of equations, and it was something like 3x plus 2y equals 8, and say x minus 4y equals 12. And basically what you have here is you had two equations that in the end would give you an x value and a y value. Now there's another way you can do it not using the calculator that you could do by graphing, and here's an example right here. And think of this as having some type of an equation, right, solving for y, and say you had to solve this guy here for y as well. You could throw those into your calculator, and then those are going to create a point of intersection like this here. And xy is how you would set up an ordered pair. So that's what we're going to look at today. So if you were graphing a question like this one, and it wanted to know what is the solution of this system, well, you would just count and find the point of intersection, which would be 1, 2, 3, 4, and then it would be up 1, up 2, so the solution here would be 4, 2. X is 4, y is 2, and there it is, choice 3. Right? So that's how they can kind of present it to you as a word problem. Now let's look at again, this could be a word problem with multiple choice, where they're just going to say, tell me the value of x and y, and you could just use your calculator, but they're not going to give you the graph. So let's do this. So in order to graph any equation, you have to have it in the form of y equals mx plus b. So you need to basically get the y by itself, which is good here for our first equation, but not so good for our second equation. So 2x plus y is equal to 5. Now in order to get the y by itself, you want to move the 2x. And remember, to move anything, you want to change its sign. So if you're going to try not to think too much, remember you can't do 5 minus 2x and write 3x because, well, one has an x and one doesn't. So you would leave it 5 minus 2x is 5 minus 2x. Or if you're going to keep it in that form, you can write negative 2x plus 5. Both are the same. So now you have two equations right there, and what we can do is go ahead and throw those right into our calculator. So my first equation here, go to the y equals, was 4x minus 1, 4x minus 1. And then the second equation, again, doesn't matter how you put it in, as long as you have your signs correct, is 5 minus 2x. You hit graph, and there it is. There is your solution. Now, you could always hit second, trace number 5, then you're going to hit enter 3 times, enter, 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 and it'll tell me that the solution is 1, 3. And if it was multiple choice, I would go, would I find x1, y3, and circle that answer. But here they're asking us to actually graph it. So in order to graph it, what we can do is we can go to our table, second graph, and to graph a line, it's best to have 3 points, okay? Okay, some people say, oh, well, I could just do 2. Well, yeah, technically you could just do 2 points and connect those two. But what happens if you did one of those wrong? There's nobody there to check you. So that's why 3 is always kind of the best way to go about this. And for an equation, for linear equations, you can go ahead and pick any points you want. Okay, it does not matter which 3 points. Well, I'm not going to use 3 and 4 because those numbers are big. I would use something like maybe you can go up into the negative space up here. And remember, this -1, -5, 0, -1, 1, 3, that represents the equation that you put into y1. And then -1 with 7, 0 with 5, 1 with 3, that represents y2. So you would go ahead, you would copy a table down onto your paper here with y1 and y2. I'm just going to really quick go ahead and sketch it. Okay, 1, 2, 3, 4. It's kind of an old school way, doing it by hand here. And also, it's best when you're doing it to go ahead and use a straight edge, because if you don't, then you could be off by just a little bit, and then you're not grabbing the correct point of intersection. And then if I'm going to do y2, what would we say that was 5 minus 2x? We'll go there. Again, nice straight line, best you can. So you have your two equations. Now, because we have two equations, it's always a good idea to label them, okay, give them their names. Okay, I can circle that point of intersection, and similar to what the calculator just said, my point of intersection was 1, 3, and there you go. That's how you're going to graph a system of equations. All right, so just one more question, everybody. And then this is going to be a word problem type question where they're not giving you the equations and you have to write it yourself. So at Ron's Rental, a person can rent a big screen television for $10 a month plus a one-time wear and tear fee of $100. At Josie's Rental, the charge is $20 a month and an additional charge of $20 for delivery with no wear and tear fee. So if C equals the cost, write one equation representing the rental for M months at Ron's Rental and one representing the cost in months for Jesse's Rental. So I'm going to do it down here because I have a little bit more room. So we have Ron and we have Josie. Now remember, the equation of a linear is mx plus b. M represents your slope and b represents your y-intercept. Your y-intercept is where you're going to begin all equations, and then this is how you're going to move. Now if you relate this to a word problem, when you begin, you can only begin at one spot at one time. It only happens once. But when you move, you will continue to move, and slope is constant, so you're always going to move in the same way. So when you go back and looked at the way they were describing the word problem, it says, Ron charges $10 a month and a one-time $100 fee. Okay? So if you're getting charged $100 a fee, that's only going to happen one time. That is going to represent your B value. And then, okay, now the question said cost, so I have to do C because it told me to. They're going to charge you $10 per month. Well, that happens every month and it's constant, so it's 10M plus 100. Josie, okay, Josie was a little bit different. She charges you more per month. So that's at $20 per month, but her fee is less at $20. Okay, so that happens to be, and that's how you're going to create your two equations. All right. Now you can go ahead and use our calculator. Let me just double check that I had the right numbers there for Josie, which was $20 a month and a $20 difference. Okay, good. So now we'll go ahead, we'll throw this to our calculator. And the one thing I'm going to notice right away is, well, look at the way they gave this graph here. They gave you the x just goes from 0 to 12, and your y goes from 0 to 240. So we're going to have to try to keep that in mind because that's not how a graph, remember, a graph is only a 10-10 graph. So let's go ahead and put that in. So one was 10x plus 100, and then the other was 20x plus 20. And then we hit graph. And the first thing you're going to notice is it doesn't look anything like the graph that they gave us. And that's because we're going to have to adjust our window. So, and again, this one's a nice one because they gave me the numbers. The x minimum was 0. That's the smallest x value. The x maximum was, what was that, 12? Okay, makes sense because there's 12 months in a year. Oh, I'm all over the place here. Okay, so here we're going to go to 12. Now the scale is just what they're counting by, and it looked like they were counting by ones. The y minimum, the smallest y value was 0, and then the largest y value was 240. And then if you look over here, well, what are they counting by? 10, 20, 30, 40. So it looks like they're counting by tens. So I could put tens, and it doesn't really matter if you even adjust the scale. Hit graph, and then there you go. You could see two equations, you could see the whole thing, I could see where they intersect, so I could go second, trace 5, enter, 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 and it notices that they intersect at 8, 180, okay? Now, to get these two graphs onto my graph here, I would go to the table, and I would graph it, okay? It looks like it goes 0, 110, 1, 110, 0, 100, 1, 110, 2, 120, and you can graph, again, 3 is enough with a ruler, or you can graph them all, 0, 0, 20, 40, 60, 80, 120, okay? Okay, and it's always a good idea to make sure that you go ahead and use a ruler when you're doing it. Okay, and then the other one started at, what was it, 100, and then it was going by tens. Okay, using a ruler. Was that what our point of intersection was? I'm just kind of graphing it here quick to make sure you got it right. And then remember, one of the things we were also kind of alluding to earlier on other videos, you can always find a point of intersection from a table because they're going to have the same y values. So I'm pretty close here. So I can see that these guys are intersecting here at 8, 180. Okay, again, it's always a good idea to write their names. So we had 20x plus 20 for this guy, and we had 10x plus 100 for that guy. They intersected at 8, 180. Label each equation, did that. Determine in which month will Josie's cost and equal Ron's cost. So it's at the 8th month. So at 8 months, they will both cost the same amount. And if they ask you, well, which one is cheaper if you're doing for less, okay, so it's cheaper to use Josie before 8 months because Ron is more expensive. But then if you're renting it for more than 8 months, then it would be cheaper to go for Ron than it would be for Josie. And that's kind of the why they have these types of equations here. Hope that helps. Hit the subscribe, like button, leave a comment. If you have any questions, please let me know. Have a great day.